Module 2, there is once again part A and part B. The part A consists of microwave network theory, and the second part of module 2 is microwave passive devices. You will be studying about the several microwave passive devices, which will also be using that in the lab, okay, in the microwave lab. In a communication system, one of the part is a microwave part. So there nearly 4 to 5 experiments whichever you perform, for all those these topics will be important for you. Okay. So starting with the first one, that is microwave network theory. In microwave network theory, the topics what you are studying is the introduction to microwave networks and the symmetrical parameters of the microwave network, and you'll be learning to represent the S matrix, represent the multiport network using scattering parameters, and you'll be studying about properties of S parameters, and finally the comparison of the S parameters with the basic parameters. Okay, so I hope you people are familiar with the network analysis, which you have studied in your third semester. In network analysis, basically, you studied about the various methods where you are able to analyze the basic circuit. That is the circuits whichever is operating at low frequency. That is from around 50 hertz and up to the range of around 50 or 20 kilohertz. Whatever the frequencies that operates or is up to around 100 kilovolts, whichever the circuits are operating, you are able to analyze those circuits by use of the KVL equations, KCL equations, and also you can one of you list down what are the theorems that you studied in network analysis? Hmm? So I hope at least you know a few of the theorems which we'll be using. That is maximum power transfer theorem, reciprocity theorem, Thevenin's theorem, and all.
Superposition.
Yeah, superposition theorems. All those theorems are the one which you are used to analyze the networks, which are low frequency networks. But those theorems what you have studied, if you want to make the same theorems or as some assumptions which are you have studied over there, you cannot analyze a microwave network, because the main reason is the microwave network is a network which carries high frequency in it. Whenever the signal propagates at a higher frequency range, we find it difficult to analyze the systems because we don't have appropriate devices to measure the microwave frequency, and we don't have appropriate devices which can display the microwave power or as a microwave frequency, the voltage and the current of a microwave signal. That's the reason why we cannot apply those theorems or as those analysis for this microwave network. Okay, so further you will just know about all this. So first of all, before all that, let us know what is a microwave network. A microwave network is a network which is formed when several microwave devices such as sources, attenuators, resonators, filters, amplifiers, etc. are connected together by means of a transmission line or a waveguide of a microwave signal. Means in the last few classes, I have shown you the microwave test bench where it consists of klystron power supply, the klystron tube, the attenuator, isolator, the slotted link carriage, and finally the mass terminator which is connected to CRO. I have already shown you the entire microwave test bench setup. in the previous module. Okay, so like that, when we connect the active devices and passive devices together, they form a network which is called as micro network. And all those devices whichever we connect will be operating only in micro frequency range. Okay, so that is what we call it as a micro network. A microwave network is a network which is formed when several microwave devices are connected. So I'll just once again show you the photo of the micro test bench, which I have shown you in the earlier class, so that I think you can remember better. So let me just show you the same. This is what we call it as a micro test bench. So here you can see three devices are connected. One is the attenuator, that is black one is the attenuator. The gray cylindrical structure is the wave meter, and after that it is the slotted end carriage. Okay, and this is what we call it as slotted end carriage. And finally the gray material which you are seeing, light blue type of material which you are looking, is the mass terminator. Like this, whenever several devices are connected together, they form a microwave network. Okay, so that is what we call it as microwave network. So a microwave network is a network which is formed when several microwave devices are connected together to perform some operation. So which are those devices? The devices may be active devices, or else the devices may be passive devices. Okay. So the sources are the active devices, whereas the attenuators, resonators, filters, amplifiers, whichever we connect, they are all passive devices. Okay. So this is what a microwave network is. And in a microwave network, always all the type of devices which we connect will be a microwave guide structure. Why do we call it as a microwave guide? Is whenever a signal travels from the input from a microwave source, they are allowed to travel in a closed surface. And this closed surface is what we call it as a guide. Okay, the surface, the layer whichever the signal travels is called as a guide, and here the microwave signal will propagate. So that's why whenever a signal, microwave signal, is guided in a closed structure, which is a hollow structure, that forms a waveguide. Next, what is the difference between the port of a low frequency network and a microwave frequency network? So let me just take an example of a network where, if I just take an example where you are connecting a attenuator. Let me take an example of a simple circuit, that is low frequency circuit, and let me take into consideration that there are three resistors which is connected in the circuit, R1, R2 and R3. Sorry, R3. Okay. So if I want to show the working of a, or else analyze the circuit, we are using the concept of H parameters, Z parameters, Y parameters. Then what I will do is, always I consider the circuit to be a low frequency circuit. Okay. In a low frequency circuit, always whenever the circuit has to work, we'll give an voltage which is called as input voltage. And the voltage which is obtained across the output is called as V naught, that is output voltage. And output voltage we may measure it directly, or else we may connect a load resistor RL and we will be able to observe what is the output voltage. But in between this input voltage and the output voltage, whenever the input voltage is given as there is a resistor, there is a parameter which is known as current. So the current I1 is in loop 1 and the current I2 is in loop 2. Okay. So now we will be able to analyze the parameter where the input voltage is V0, Vin and the output voltage is V0. And similarly, we'll also be able to know the parameter I1 and I2. That is the current in the loop 1 and current in the loop 2. So like this, when we want to analyze a low frequency circuit, we can know what is the input voltage and what is the output voltage, and also we can know what is the current in accordance to the input given. Because we can give the input ranging from 1 volt and up to 12 volts as input. Let me just take it an example. You can give a minimum voltage of 1 volt under low frequency. This is a nominal thing. What we can do, we'll connect the components circuit. We'll be able to analyze what is the input voltage and what is the output voltage in accordance to the input given, and we'll also be able to measure the current using the ammeter and the voltage using the voltmeter. But if I want to analyze the same thing, I think using for a micro signal, it is not possible by this method. Okay, because the devices which we connect are complex. That's the main reason. And here one more thing is, here we don't call it as ports, we call it as input terminal and output terminal. Do you call it as port? Already you have analyzed few of the low frequency circuits, right, in a network analysis. Have you ever called the input and output as ports, or else have you called it as input terminal and output terminal?
Terminals, ma'am.
Yeah, you call it as terminals because uh, the yeah, there is an input which is a terminal where, and this is the output which is an output terminal. We call it as terminals. But when we try to represent those things in terms of microwave network, in microwave network we call it as ports, because there are multiple things which is happening at the input, and there are multiple parameters which you can analyze at the output. So in a micro network, we call those things, the input and output as ports and not the terminals. Okay. And one more thing is, if I want to open circuit or else if I want to short circuit this low frequency circuits, it is very easy. I connect a low resistor and I will terminate the circuit. I'll just block the output and I will short circuit the connection. Or else if I want to make the signal flow, then I'll open circuit the connection. Okay, it's very easy. But the microwave circuits are not like that, or as the micro networks are not at all like that. It is very difficult for us to either open circuit the micro network or else short circuit the micro network, because the main reason is the signals will be traveling at very high range. So due to that, it is difficult for us to analyze the microwave networks. Okay. So coming for network ports, that is micro network ports. What is the difference between the port of a low frequency network and a micro frequency network? Here in a low frequency circuit, whenever I give a input voltage, there is no reflected signal. But in a microwave network, whenever I give a input voltage, always there is a reflected voltage which is called as VR, because the reflection will take place because the signals are traveling in a surface. The signals are traveling in a waveguide structure. Okay. So for that purpose, always for a incident voltage, there is a reflected voltage, or as for a incident power Pin, there is a reflected power which is PR. Okay. And whenever we want to analyze the low frequency networks, low frequency type of networks, then the performance can be analyzed by use of Z, H, Y and ABCD parameters. Okay. But when I want to analyze the microwave network, the microwave networks cannot be analyzed by use of Z, H, Y or ABCD parameters. We make use of a other special type of parameter which is called as S parameter. So what does this S stands for? The S stands for scattering parameter. Okay. So scattering parameter means whenever a signal travels in a waveguide, whenever a signal travels in a waveguide structure, the signals scatter. Okay, completely the microwave signals will scatter whenever there's an open space. That's why we call the parameters as scattering parameters. So the S parameters or the scattering parameters are the parameters which are utilized to analyze a microwave network. But to analyze a low frequency network, we can make use of Z, H, Y and ABCD parameters. So, we should know what is the reason why we are not able to make use of Z, H, Y and Y parameters to analyze microwave network. First of all, the basic important reason is the physical length of the device. Whenever we consider a microwave test bench or is when we take a microwave device, the physical length of the device is very high. Means the space occupied by microwave device is small. And the signal strength whichever is traveling, the order of frequency is also high. And whenever the frequency range that is propagating in the device is high, it is not easy to analyze the current and voltage parameters easily for a microwave structure. Okay, so that is the first reason. There's the physical length of the component is much greater than the wavelength. So whenever the wavelength of the signal is greater than the physical length, the voltage and current at a given point cannot be defined exactly in a microwave circuit or as in a microwave network. These are the two important parameters. One is the physical length of the device is more and the wavelength is also more. The frequency of operation is also high. And as the circuits are operating at higher frequency, we cannot measure the voltage and current at one particular point of time because we don't have the micro devices which can measure the microwave voltage or is the microwave current, right? So that's the purpose why we cannot analyze the microwave networks using this Z, H and Y parameters, but instead we go for a parameter which is called as scattering parameter. And the second condition why we go for S parameter to analyze the microwave network is the microwave networks cannot be open circuited or short circuited easily. Open circuiting or short circuiting of a microwave device is very difficult. That's the reason why we cannot make use of the Z, H and Y parameters to measure the microwave network parameters. So this is what the low frequency analysis. If I want to analyze a low frequency network, this is my low frequency network. So yeah, the low frequency network, as you all know, whenever you give a input voltage, it will have the positive and the negative terminal, and a voltage is applied between this positive and negative voltage terminal, because as you know, on the power supply you have the positive and the negative terminal. The positive is given to the circuit and the negative is given to the ground. And in same way, whenever I want to get the output voltage, that is in this circuit we have shown it as V1 and V2. The output voltage is V2. So here I have the positive and negative terminal where the output will be measured. And whenever there is a voltage that is given to circuit, there is a current flow I1 and I2. Okay. So by this we can analyze the low frequency circuit by use of the various parameters, where here they are given an example, that is we are expressing the Z parameters in terms of voltage V1 and V2. So finally we can analyze the parameters in Z, Y and H parameters. So we can get the equation for voltage and current in terms of H parameters, if it will be V1 is equal to H11 I1 plus H12 V2, and the output current V2 will be H21 I1 plus H22 V2. So by this equation, we'll be able to know what is the input voltage and what is the resulting current. As the resulting current is I2, I'll be able to measure what is the input voltage and the corresponding output current by means of equation itself. So like this, we'll be able to analyze the low frequency circuit because the frequency is limited and the voltage and measuring device, current measuring devices are available for low frequency range. Okay. So the three reasons why the Z, H, Y and ABCD parameters are difficult to measure for microwave circuit. Okay, we will not measure these parameters for a microwave circuit. Always we analyze we can measure the S parameters for a microwave circuit. You will come to know what is S parameters later. So the three reasons are non-availability of terminal voltage and current measuring equipment. When we work with a microwave signal, we don't have the devices where it can measure the terminal voltage or the terminal current. Okay. And second one is short circuit and open circuits of a micro circuits are not easily achievable. And the third one is presence of active devices, that is the Klystron power supply which we are using, that is the active device, will make the circuit unsuitable for short circuit and open circuit. There will be very much unstable. Okay. So these are the three reasons why we cannot make use of Z, H and Y parameters or the ABCD parameters to analyze a microwave circuit. Okay. So now we have covered with these topics. One is what is a microwave network? So a microwave network is a network which is formed when several microwave active and passive devices are connected by means of a transmission line. And secondly, we also came to know what is a network and why do we call it as ports in a network. And next, we also came to analyze about the low frequency circuits and why we can make use of Z, H or Y H and ABCD parameters to analyze the low frequency circuits by means of this equation. And finally, we came to know what's the reason that we cannot analyze the microwave networks or as a microwave circuits by means of Z and Y parameters. That is, what is the purpose for us to study the scattering parameters or as the S parameters. Okay. And from this topic, there would be a short answer question which is asked in the exam. Just very direct and simple question. Explain why Z, H and Y parameters cannot be used for measuring the microwave parameters or as for analyzing a microwave network. These are the three reasons which you should quote. And these three statements will fetch you directly 3 marks. Okay. The first one is non-availability of terminal voltage and current measuring equipments. And the second reason is short circuit and open circuiting conditions for a microwave network is not possible. And the third one is the presence of active devices will not help the circuits to be short circuited or open circuited. And the entire signal will be getting scattered inside the junction or else inside the port. That's the reason why we don't make use of the Z, H, Y or ABCD parameters to analyze a microwave network.